Imagine walking where dinosaurs once roamed. We cannot see these magnificent creatures alive today, but they left behind clues. Fossilized bones tell us about their bodies. Yet there is another type of fossil. These remarkable records are dinosaur trackways. Dinosaur trackways are series of footprints. They are preserved in ancient stone. Each print is a moment frozen in time, a heavy foot pressed into soft mud. The sun then baked it hard. Over millennia, layers of sediment covered these prints. They slowly turned into rock. This process preserved them for us to find. These trackways are incredibly valuable to science. They are what we call trace fossils. Unlike body fossils like bones or teeth, trace fossils record activity. They can tell us how a dinosaur walked. Did it walk on 2 legs or 4? Did it move quickly or slowly? Sometimes trackways show dinosaurs moving in groups. This suggests social behavior, perhaps herds. Studying these footprints is a special kind of detective work. Scientists meticulously measure each print. They note the distance between them. Dinosaur trackways are truly windows onto a lost world. Deep in eastern France lies a region of rugged beauty. The Jura Mountains stand tall and proud. Their limestone rocks hold many secrets. These secrets are ancient, dating back to the Jurassic period. This was a time when dinosaurs dominated the Earth. Around 150 million years ago, this area was very different. It was a vast, shallow tropical sea, dotted with low-lying islands and tidal flats. On one of these ancient tidal flats, a truly remarkable discovery was made. Near the small village of Plagne, something extraordinary lay hidden. It was hidden beneath layers of earth and vegetation. For countless centuries it waited patiently. This story is written not in words, but in stone. It is a story of colossal creatures that once strode across this very landscape. The discovery we speak of is a dinosaur trackway, but not just any trackway. This is the longest sauropod trackway ever found anywhere in the world. Imagine the scene, a giant long-necked sauropod dinosaur, walking slowly, deliberately across the soft mud. These impressions, over vast stretches of time, became fossilized. They formed an incredible prehistoric highway. The Plagne trackway is truly staggering in its scale. It stretches for an incredible 155 meters, step after step for such a distance. It gives you a real sense of the animal's journey. This remarkable length makes it unique. Scientists have identified 110 distinct footprints, each one a clear mark of a massive foot. These prints are arranged in a clear sequence. The preservation is remarkable. The footprints themselves are enormous. Many measure around 1 meter in diameter. Standing beside one, a human would feel very small. So what kind of dinosaur made these colossal footprints? Scientists have given a name to the trackmaker. Based on the unique characteristics of the prints, they call it. Brontopodus means thunderfoot, a very fitting name for such a giant. Plagnensis refers to Plagne, the village where it was found. This name helps to classify the tracks, and to discuss the animal that made them, even if we don't have its bones. From the size and spacing of the footprints, we can estimate the dinosaur's dimensions. This was no small creature. Scientists believe was a truly enormous sauropod. It likely measured at least 35 meters in length. That is longer than 3 double-decker buses parked end to end. Its weight would have been equally impressive, perhaps around 35 to 40 tons. Imagine its immense form moving across the landscape. The trackway also tells us about its pace. This giant was not in a hurry. The spacing of the prints suggests a walking speed, a rather leisurely one at about 4 kilometers per hour. These sauropods were herbivores, gentle giants browsing on the vegetation of the time. The Plagne tracks provide a vivid snapshot. The story of the Plagne trackway's discovery is fascinating. It began in 2009. 2 amateur fossil hunters, Marie-Hélène Marceau and Patrice Landry, were exploring the area. They stumbled upon something unusual: large, circular depressions in the limestone rock. They suspected these might be dinosaur footprints. Their curiosity and keen eyes set in motion a great scientific adventure. Their find was reported to paleontologists. Experts from the University of Lyon and the National Center for Scientific Research, or CNRS, soon arrived. They confirmed the initial suspicions. These were indeed dinosaur footprints, and they were exceptionally large and well preserved. The site, located in a forest near Plagne, became a hub of activity. Careful excavation work began to reveal the full extent of this prehistoric marvel. It was a slow and painstaking process. Over several years, teams of scientists worked at the site. They cleared away soil and vegetation. They meticulously cleaned and documented each footprint. The full length of the main Sauropod Trackway was gradually uncovered. It was then that its true significance became clear, the longest Sauropod Trackway ever found. The trackway was officially named. The Jura Mountains have long been known for fossils. The Plagne site is not just about one giant sauropod. While steals the show, it was not alone. The excavations have revealed other fascinating traces, footprints of different types of dinosaurs. This tells us that the Plagne area was a diverse ecosystem, a busy place during the Jurassic period. Multiple species shared this ancient coastal environment. Among the other discoveries are tracks from carnivorous dinosaurs. These are known as theropods. These prints are very different from the sauropods. They are typically three-toed, and much smaller, though still formidable. These theropods were the predators of their time. Perhaps they were stalking smaller prey, or even cautiously watching the giant sauropods from a distance. Their presence adds another layer to the story, a story of hunters and the hunted. The theropod tracks found at Plagne are also significant. One particular trackway belongs to a meat-eater. It has been given the ichnogenous name. These prints are about 30 centimeters long, suggesting a dinosaur perhaps 7 to 9 meters in length. Finding tracks of different dinosaurs together is exciting. It helps us build a more complete picture of the local fauna. How do scientists extract so much information from mere footprints? It is a fascinating field of study, called ichnology, the study of trace fossils. It combines geology, anatomy, and a bit of detective work. When a trackway like Plagne's is found, the work begins. Each print is carefully measured. Its length, width, and depth are recorded. The angle of the toes, if visible, is noted. Every detail matters. The distance between consecutive prints is crucial. This is called the step length. The distance between two prints from the same foot is the stride length. These measurements, combined with the footprint size, help estimate the animal's hip height. From hip height, scientists can then estimate its overall body length, and even its approximate weight. It is a chain of careful calculations, based on our understanding of animal locomotion. The pattern of the trackway also reveals much. A narrow trackway suggests an animal with legs held directly beneath its body. The Plagne sauropod had a relatively narrow gauge for its size. The discovery of the Plagne trackway is a monumental achievement, but it also raises an exciting question. What else might be hidden in the Jura Mountains? And in similar geological formations around the world? The Earth still holds many secrets from its deep past. The Plagne site itself was exposed over a large area, but it is likely that the track-bearing layer extends further, perhaps under more forest cover or deeper underground. Paleontologists believe the Plagne region has high potential for further significant fossil discoveries. The conditions during the late Jurassic were ideal for track preservation. Large expanses of tidal flats, regular, gentle sedimentation to cover and protect the prints. The limestone layers of the Jura are rich. They have yielded many fossils over the years, from marine reptiles to ammonites, and now world-class dinosaur trackways. There is surely more to find. Future exploration might involve new technologies. Ground-penetrating radar, for example. This could help identify potential track sites. Without the need for extensive preliminary digging, remote sensing and detailed geological mapping also play a role, guiding researchers to the most promising locations. However, the keen eyes of amateur enthusiasts, like those who first spotted the Plagne tracks. The Plagne Sauropod Trackway is more than just a record breaker. It is a profound connection to a lost world. It allows us to walk, in our imagination, alongside one of Earth's largest ever land animals. The sheer scale of the tracks, the length of the pathway. These things evoke a sense of awe and wonder. They remind us of the incredible diversity of life that has existed on our planet over geological time. This discovery has immense scientific significance. It provides invaluable data on sauropod locomotion, their size, their speed, their herd behavior, if multiple trackways are found. It helps refine our understanding of these giants and how they lived in their environment. The presence of theropod tracks alongside adds ecological context. It offers a glimpse into the community structure of a late Jurassic coastal ecosystem. It is a rich scientific resource. Beyond the science, Plagne has an educational and cultural legacy. It captures public imagination. It inspires young people to learn about science and prehistory. Sites like this can become focal points for education, for tourism, and for local pride. Preserving and studying such a site is crucial. It ensures that future generations can also marvel at these tangible links to our planet's ancient past.